Howdy folks, let's talk about the weather together. I'd like to start off with the demo.
Weather Together is a weather guessing game. You will receive a randomly generated weather data set. You will then pick a location on the map that you think most closely matches the weather data you were given. You will receive a score where 0 is the best possible score, kind of like golf, and 20,000 is the worst possible score. I'm going to go ahead and head over to our login page. Just going to toggle the theme here so you see that we do have a dark and light mode. And then I'm going to sign in. Just take just a second. Okay, so we're logging in. So this is our weather data set that we're trying to get closest to. I'm just going to try to pick something not really that close, but just something to show you how it works. We can submit our guess. And so this should be closest to Winthrop there, it says. So it's going to show you a picture of the closest location that has a picture for. We then also have a wiki page here if you want to learn more about that place. It'll show you that total score. Not great, not terrible. I'm going to go to the dashboard. It's going to show you our daily game stats. This is how many times we played it and all of the stats where our scores lie. We also have a competitive game mode, which is a forecast, so you're guessing 3 days in the future. It also will give you a rank here of how you're doing in that competitive stats. That is against everybody in the entire website. Anyone that's a part of it is there. It'll also show you your last 3 games played. And it will send you an email once that 3 days is up and tell you how you do in each individual game. And then there's custom games that you can create here for you and your friends. I'm going to go ahead and create a new one for us. I like the Fighting Hens. It's a great name in my opinion. We're going to create this for 100 days long, and our guess lead time is going to be 2 days. So it's similar to the competitive game in that way that you get to change your lead time. And I'm just going to invite myself because I am actually on Michael's account here. So whenever I add myself, it's going to show you the invitees. We can go ahead and create the game. It'll show you the leaderboard there. No one scored anything yet.
This application was built using several languages and frameworks across 3 different repositories. We had our primary backend repository that was built using Rails and Ruby that houses the majority of the game logic. We had our location information microservice, which was built using Java and Spring Boot, that gathers information such as images and a Wikipedia article on locations where votes were submitted. And we had our front-end repository that was built using React and a combination of TypeScript and JavaScript that houses the logic for the user interface. Now for a little more in-depth view at the backend. As mentioned previously, the Rails repository executes the bulk of the game logic. The daily game processes votes synchronously, while the competitive and custom games process their votes asynchronously once a day using cron jobs. The location information microservice agglomerates info from several restrictive APIs to deliver for the daily game vote. It will try and find information for the most specific location possible using available API calls and some prior requests that are stored in a database.
We decided to tackle optimization in some portions of the backend portion of the Rails app. And the first thing we implemented was Honeycomb, which was a general observability tool, and it shows us stuff such as current errors, the slowest API calls, and how long they take. And we can drill down and take a closer look at the stack trace of any of those slower API calls to get a better idea of what's going on. And this really informed the team of the slowest points for any user and how we could implement some changes, either using caching or a background worker somewhere in the backend portion to kind of speed up any of the processes.
Hi, I'm Ben, and I was one of the team members on the front-end side of the application. One of the main challenges that front-enders faced was the large size of the application. Because of this, the backend and front-end team worked together to complete this portion of the project. We used React functional components that could be reused again when necessary, such as for the header, map, and footer. Additionally, TypeScript was used while building this application. In TypeScript, some errors that would only be caught at runtime in JavaScript were instead caught while compiling. This was particularly helpful to backenders who are trying to learn front-end, as many errors were caught far earlier. Brendan used React Router to implement a multi-page application. He used local storage as well to implement sessions. Despite the large size of the application and the large team, we were able to avoid letting things slip through the cracks, and we were able to achieve a cohesive product.
I'm Tommy Takahashi from the backend front-end team, and I'll be talking about a couple of front-end features that we added to our app. We utilized the Lottie React library that enables a seamless integration of Adobe After Effects animations, which we exported as JSON files and then implemented into our app. We also implemented the ternary light and dark React hook to dynamically add a switch feature, which toggles between light and dark color schemes based on the user's preferences.
Thanks for coming. Here's a list of all our contributors. Thanks, guys. Go out and explore some weather together.